Section 9.5 is distance and midpoint formulas. I can use the distance, midpoint, and slope formulas. To find the distance between 2 points A and B in the drawing on page 476, we can draw in a triangle. The distance is the hypotenuse of the triangle. The lengths of the legs are the length from A to C and from B to C. So if we look there on page 476, we can see our 2 points. They're not in line vertically or horizontally, so we need to draw in that triangle. And when we do, it's a right triangle. So we can use Pythagorean's theorem to find the length of AB. And it's the distance between the 2 points. So another way that we can do that, guys, is we can use our distance formula here, which uses the Pythagorean theorem. It just has it in a different way, so it's a little bit easier to use with our coordinates. So the distance between 2 points in a coordinate plane is equal to the square root of the sum of the horizontal change squared and the vertical change squared. This looks like a lot, guys, but we're just finding one of our side lengths, the change in our x's, the other side, the change in our y's, and using our Pythagorean theorem. C squared equals a squared plus b squared. So we take our side length from x to y, our change in x's, and square it. We take our side length between our y values, the change in y's, our b value, and square it. And then don't forget to get rid of our square. We have to take the square root of both sides. So this is really just like c equals the square root of a squared plus b squared. It just looks a little bit different here, again, because we have ordered pairs, so it lets us plug in those points. So in example 1 here, we're going to find the distance between our 2 points. We're going to start off with our distance formula. It's our change in x's squared plus our change in y's squared. Remember, in ordered pairs, x's are our first coordinates and y's are our second coordinates. So I'm going to keep my formula exactly as it's written to set up my framework. The only difference is I'm going to plug in my values. So again, my parentheses, my subtraction, my squared, my adding, all of that stays the exact same, my square root. I just plug in my values. So x is 6 minus x is 5. And y is 3 minus y is 7. And now we just simplify this according to PEMDAS. PEMDAS says we do whatever's inside our grouping symbols first. So we have to do everything inside of our square root. And inside our square root, we do parentheses. 6 minus 5 is 1 squared. 3 minus 7 is negative 4 squared. And we keep the rest of that exactly as it's written, the square root, the plus, the exponents. Now, according to PEMDAS, we do our exponents. 1 squared is 1. Negative 4 squared is positive 16. Every time we square a number, guys, it's going to be positive because we're taking the same number times itself. So negative 4 times negative 4 gives me a positive 16. Just like a positive 1 times a positive 1 gave me a positive 1. And now we can finally add, and we get the square root of 17. So our distance here is the square root of 17. And we want the exact answer in simplest form. So here 17 is prime, but if it wasn't, we'd try and take out any perfect squares. We don't want the decimal approximation there. We want the exact answer. So again, in number 1 here, feel free to pause and give this a try if you'd like. We're going to use our distance formula. In our distance formula, we subtract our x's, square it, and add it to the value we got when we subtracted our y's and square it. So our change in x's is like our a value that we squared, plus the change in y's is like our b value that we squared. And we take the square root because that's how we get the c, or our distance, by itself. Again, remember, x's are our first coordinates. So here I have 11 minus 7. And y's are my second coordinates in each ordered pair. So negative 2 and negative 5. And we subtract a negative, we add. Now, according to PEMDAS, we're going to do our parentheses first. 11 minus 7 is 4 squared. Negative 2 plus 5 is 3 squared. Now we can do exponents. 4 squared is 16, and 3 squared is 9. 16 plus 9 is 25. And now 25 is not prime, so we can try and break that down. 5 times 5. So I have the square root of 5 times 5. A pair of 5s comes out as a 5. I don't have anything left inside, so all I have here is 5. 5 is the square root of 25. I'm going to try another one here. Again, I'm going to start off with my formula. It's our change in x's squared plus our change in y's squared. Again, our change in x's is our a value, our change in y's is our b value. A squared plus b squared equals c squared, so we take the square root to get that c by itself. Here, our distance. X's are the first coordinates in our points, so -1 minus 5. Y's are my second coordinates, so 3 minus -2. We keep our formula, and now we simplify. PEMDAS says we do parentheses first, so I get -6 squared. 3 plus 2 is 5 squared. Make sure if you're going to type these in your calculator, guys, you put parentheses around your -6. It's a good habit to get into to just put them in there all the time anyway. Or we know that negative times a negative is a positive, so just make sure you double check that. We're not going to get -36 here, we're going to get positive 36 when we take this exponent there. 5 squared is 25. Final step, we can add those up and get the square root of 61, which we can't break down any further. For 3 here, start off with our formula. And our framework again is a square root where we subtract our x's and add to it, subtracting our y's. X's are our first coordinates, so 0 minus 10. Y's are my second coordinates, -1 minus -5. And when we subtract a negative, we add. 0 minus 10 is -10 squared. -1 plus 5 is 4 squared. -10 squared is positive 100. 4 squared is 16. So we get the square root of 116. And keep in mind, we want to try and break it down if we can. So using my factor tree here, I get 2 times 58, which is 2 times 29. So I get the square root of 2 times 2 times 29. I have a pair of 2's, so I'm going to take that pair out as a 2, and now it's not inside anymore. So D equals 2 times, all I have left inside my square root is the 29. And that's our answer in simplest form. The midpoint of a segment is the point on the segment that is equally distant from the endpoints. So the midpoint formula here, we're going to find the average of our x's and the average of our y's. So to find the midpoint, we're going to add up our x's and divide by 2 because we're finding the point halfway between 2 points, which means we're always going to have 2 x's and always going to have 2 y's. So we add up and divide by how many there are. Add them up, divide by how many there are. Again, we're finding the middle, the average of our coordinates, and we write it as a coordinate, as an ordered pair, because it is a point that's directly in the middle. So we add up our x's, divide by 2, add up our y's, divide by 2 to find our midpoint. So in example 3 here, we're going to find our midpoint. Remember, it still is a point, it's just our middle point. So we're still going to write it as an ordered pair. We're going to find our average. So we're going to set it up, add up our x's, divide by 2 because we have 2 points, add up our y's, divide by 2. Again, we're looking for the middle, we're looking for the average. X's are the first coordinates, so 3 plus -9. Y's are our second coordinates, 8 plus -4. We're going to add first, negative 6 divided by 2, and positive 4 divided by 2. And then we reduce. I get negative 3, positive 2. So the point that's directly in the middle of 3, 8, and negative 9, negative 4 is negative 3, 2. Slope here, we're going to do the same way that we've been doing since chapter 8. So as long as they're not on a vertical line, we can use coordinate notation to write the formula for slope. We're going to subtract our y's, divide by subtract our x's. So to find the slope of the line here, again, we subtract our y's over our x's. It's rise like our y's over run like our x's. Again, coordinates are x first. So I can do 3 minus 8 as my x's, and then y's. Since I used 3 first, I have to use 7 first. And negative 3 minus negative 3. When we subtract a negative, guys, we add. So here, I get 10 over negative 5, and my slope is going to be negative 2. Now, feel free to pause here and give this a try if you'd like. The midpoint is the point that's in the middle. And again, when we're talking middle here, we're going to talk averages. So to find my midpoint, I want the ordered pair. And to find the average, we add them up and divide by how many there are. And we have 2 points. So my x's go together to find the average of my x for my x coordinate, negative 7 plus 5. My y's go together to find my y coordinate. Negative 7 plus 5 is negative 2. When we divide that by 2, I get negative 1. 1 plus 11 is 12 divided by 2 gives me 6. So negative 1, 6 is the coordinates of my midpoint. Now to find the slope here, remember slope is rise over run. We subtract to find our change in y's, and then we divide by our change in x's. And to find our change, we subtract. X's go together, and y's go together. So 7 minus 5. Since I use 7 first, I have to use 2 first, minus negative 3. I get 2 over 5. Now, using these same points, I'm going to swap and find the slope here. So to find slope, we subtract our y's and subtract our x's. We find our change, and to find change, we subtract. Again, y, 11 minus 1. Since I used 11 first, I have to use 5 first, minus negative 7. I get 10 over 12. Reduce if you can. Here they're both even, so I can take a 2 out of both, and I get 5 over 6. For number 6 here, I'm going to find the midpoint of these 2 points. So to find the midpoint, I'm looking for the coordinate that's in the middle. I'm going to average these. I want to find the middle x, so I add them up and divide by 2, and the middle y coordinate, so I add them up and divide by 2. X is here, 2 and negative 3. Y's, 7 and 5. 2 plus negative 3 is negative 1 over 2. And 7 plus 5 is 12 over 2. Reduce if you can. Negative half doesn't reduce, but 12 over 2 reduces to 6. And here is my midpoint. So negative 1/2, 6 is the point that's in the middle of those two. It's the halfway point between them. And that's all I have for section 9.5.